Hey there, and welcome. Have you ever looked at your phone or your computer and just wondered, how does it all work? Well, it's packed with tiny parts, and today we're zeroing in on one of the most important ones, the diode. It might not get all the glory, but it is truly the unsung hero of all modern electronics. So let's dive in and see what makes this little guy so special. You can think of electricity in a circuit like traffic in a big city. If you don't have any rules, no stop signs, no one-way streets, you just have total, absolute chaos. So the number one job for an electronics engineer is to control that flow, to tell the current where it's supposed to go, and maybe even more importantly, where it's not supposed to go. And this is how they do it. Meet the diode. It's an unbelievably simple component that acts as the perfect little gatekeeper for electricity. Honestly, it's one of the first things you learn about in electronics because its job is just that fundamental. So that's the big question, right? How in the world does this tiny little thing enforce one of the most basic rules of the road for electricity? Well, the answer is actually pretty brilliant in its simplicity. The easiest way to think about it is like a one-way street, or maybe a one-way valve in a pipe. A diode lets electrical current flow through it super easily in one direction, but it slams the door shut if the current tries to flow the other way. It's a simple rule, this way only, but it is incredibly powerful. And here's how we see that idea in practice. On the left, that's the circuit symbol for a diode. That big triangle is basically an arrow, and it's pointing in the only direction that current is allowed to travel. And on the right, that's what they look like in the real world. See that little stripe on the body? That line corresponds to the flat bar in the symbol, marking the exit of our one-way street. All right, so let's actually see this one-way street in action. Okay, so here we've got a really simple circuit, a battery, a diode, and a little light bulb. The diode's arrow is pointing in the direction of the current, flowing from the positive side of the battery to the negative. We call this forward bias. And look what happens. The current flows and the globe lights up. Everything is working just like it's supposed to. But watch what happens if we just flip that diode around. Now its arrow is pointing against the flow of current. This is called reverse bias. The diode basically becomes a roadblock, a dead end. No current can get through. And the result? The motor doesn't spin. The circuit is effectively broken. So the whole thing really comes down to which way you point it. Forward bias means it's aligned with the current and traffic flows. Reverse bias means it's pointed against the current and traffic stops. This simple on-off allower block function is the absolute foundation of what makes diodes so incredibly useful. But the story doesn't stop there, not by a long shot. It turns out diode is more like a family name, and there's a whole bunch of them, each with their own special talent. Let's meet a few. Actually, I'd bet money you're looking at the most famous member of the diode family right this second. It's probably on your monitor, your keyboard, maybe your mouse. Yep, it's the LED, which stands for light-emitting diode. And at its heart, an LED is just a diode. It follows the exact same one-way traffic rule, but it's got this one awesome side effect. When current flows through it the right way, it lights up. And this is just so cool to see. An LED isn't a tiny light bulb with a burning filament inside. No, it's a solid piece of semiconductor material that's specially engineered to glow when electricity passes through it. And by tweaking the chemical recipe of that material, engineers can make them glow in all sorts of amazing colors. And besides LEDs, you've got all these other specialists. Signal diodes are built to handle tiny, delicate currents in things like radios. Power diodes are the heavy lifters, made to handle huge currents. And then you have Schottky diodes. They're the sprinters of the diode world, able to switch on and off incredibly fast. Each one is a one-way valve, but it's optimized for a very specific job. Okay, so we know what they are, and we know there are different types. Now let's talk about where you actually find them making a real difference out in the world. Here's a classic example, protecting your gear. Imagine you've got an expensive car amplifier and you accidentally hook up the battery backwards. You could instantly fry the whole thing. But if the designer put in a single, simple diode, look what happens. On the left, when it's connected correctly, current flows just fine. But if you mess up, like on the right, the diode blocks the current and saves your equipment. A tiny component that costs pennies, preventing a mistake that could cost hundreds of dollars. Diodes are also absolutely critical for things like renewable energy, especially in solar panel systems. They have a couple of really clever jobs to do to make sure you're getting every last drop of power out of the sun. Okay, so first you have what's called a blocking diode. Think about it. At night, you don't want your batteries to drain their power back into the solar panel, right? This diode acts as a one-way gate to stop that from happening. Then you have bypass diodes. These are super clever. If a single panel gets covered by a shadow, you don't want it to bring down the whole system. The bypass diode lets the electricity from the other panels just go around it, keeping the power flowing. All right, so let's bring this all home. What are the most important things to remember here, especially if you're someone who likes to tinker with electronics? I love this because it's a question you see online all the time from people just starting out. It gets right to the point. Okay, we get it. A diode is a one-way street. But can you just swap any one-way street for another? And the answer is a definite no. Just look at this comparison. The 1N5822 is a Schottky diode built for power applications. It can handle 3 whole amps of current. But the 1N4014 is a signal diode. It's fast, but it can only handle a tiny fraction of that current. If you put that little signal diode in a power circuit, it would just pop. So the big lesson is you gotta pick the right tool for the job. And really, that's what it all boils down to. Whether it's letting current flow or blocking it, emitting light as an LED or protecting our expensive gadgets, it all comes back to that simple, fundamental rule of being a one-way street for electricity. It's one of the most basic building blocks we have, and it makes almost everything else possible. Which really just leaves you with one final thought. We've seen this one-way rule protect a circuit, we know it can make light, but you can also combine diodes to create logic gates, which are the fundamental building blocks of a computer's processor. It just makes you wonder, what else can we build? All starting with a rule as simple and as powerful as this way, but not that way.